Hello and welcome to the Isaac Newton Institute podcast. My name's Dan Aspel, I'm the communications manager here, and today I'm joined by Professor Elizabeth Mansfield.
Hello, Dan.
It's a real pleasure to have you here. Shall I call you Liz or Elizabeth?
Either.
Well, it's a real pleasure to have you here, Elizabeth, and we're going to talk a little bit about specifically why you're here in a minute, but it would be great to have a little introduction to yourself if you don't mind. So what's your home institution?
I work at the University of Kent. And I'm a professor there, and I'm in fact the first ever female professor of mathematics there. And 24 years ago I was the first ever female lecturer in mathematics there.
Wow. Yeah, I mean that's a huge topic in itself, and one I'm sure we can touch on later. And originally, as people might be able to tell from your accent, you're from...
I grew up in Sydney, Australia, and I was educated there. And I also... was 3 years in a graduate school in Madison, Wisconsin.
Wow, okay. So as with many people that I speak to, you've travelled around quite a lot of the world pursuit of your
I have indeed.
Specialism.
Yes.
Yeah, and what is your particular area of mathematics?
The reason that I'm here today, the reason I'm in this program is because for the last 10 years I've been really concerned with embedding conservation laws, physically important conservation laws, into numerical methods. And so my motivation comes from a story that I tell quite a bit. Some years ago now, I was talking to Ian Ralston, who's now at Surrey, but at the time he was at the Met Office, and he was telling me about how the UK Met Office, famously failed to predict a hurricane in 1987.
Yeah, absolutely.
And the story goes that they sent their best mathematicians to a think tank in Europe, and it came back that the numerical methods did not have incorporated the kinds of conservation laws that were needed to predict a hurricane. In particular, potential vorticity was mentioned. So I'm not a meteorologist, but I was immediately enraptured by this idea that the numerics should incorporate the physics, and in particular these conservation laws that are so physically important, such as conservation of energy, linear momentum, angular momentum. And I set about to prove it, even though in theory it was supposed to be impossible. But it turns out, if you're a little bit devious, that you can, and you think pragmatically, that you can actually get quite a long way with it. And that's been one of the main strands of my research in the last 10 years.
Wow. I mean, that's a fascinating collection of things. And again, there are so many points in there that we could do an entire podcast on in themselves. But that I presume, has led you to one of the reasons you're here today, which is that you're an organiser, and I'm going to have to read this because it's quite a long title. You are the organiser of Geometry, Compatibility and Structure Preservation in Computational Differential Equations, which is a programme which is running here in the second half of 2019. And tell me a little bit about the programme. Tell me about what stimulated you to focus on this, you and the other organisers. Tell me about how the idea came about.
Well, there are 6 organisers, and we all have very different points of view. Some organisers work on ordinary differential equations, which you use, say, for mechanical systems, and other organisers work on partial differential equations, which are used to model water waves and optical, waves down optical fibres and all the rest. So the points of view are very different. Numerical methods are... there's a multitude of different kinds of numerical methods, and there's all manner of pure mathematical conceptual structures that you can seek to maintain in a numerical method that you might want. So many of these come from differential geometry, or they come from the fact that your system evolves naturally on a surface, that you might want to... Your system that you're studying might preserve volume or area in some sense, and you want the numerical method to maintain that as well. So there's a very long list of things that you might want to preserve in a numerical scheme. And I suppose we're taking advantage of the fact that modern computers are quite fast, and so that you can develop these methods. You still want them to be very efficient, but nevertheless... you do have the computing power you need to do more than the bog standard simplest things. So that's why we're all here.
And yeah, when we spoke a little bit earlier before we turned on the mic, I asked you is this a pure or applied program? And you said it's a relationship between the two.
It definitely is. I do tell people that I apply pure mathematics to applied mathematics, which is maybe a little recursive. But I did train as a pure mathematician, and before embarking on my big theme to have Nernst theorem in numerical methods, I was very involved with quite pure mathematical things, and in fact symbolic computation. And maybe the fact that I had the either courage or lack of education to embark on my preserving Nernst theorem comes from the fact that I wasn't a numerical analyst, and I just gave it a go.
Yeah, sure. And you were mentioning before we introduced the program, you were saying about that sort of element of meteorology, which led into your particular interest in mathematics. And you also mentioned it in your introduction to the program as well. So are the applications that you're putting it towards, that feasibly could be used for that kind of science? Is that fair to say?
I think all of us are very open to the applications, and you want... But I have to admit that I do rely on my engineering and physics friends to tell me which differential equations I should most admire.
Okay.
And what are the most interesting variational problems to study, to which Nernst theorem might apply. I don't want to study things in a vacuum. You want you want eventually what you do to have some to have some impact, and to be used hopefully in due course.
Sure. And what I'm particularly interested in actually is that I haven't spoken to an organiser in these terms before, and I know there are 6 of you, so obviously, well, perhaps some will have done more work in some areas than others, or maybe all 6 of you are spread perfectly evenly across the responsibilities. But tell us about what it's like proposing, having accepted, and then running a programme here at the Newton Institute.
Oh, well, it's very exciting. You have to think big. You want to have a grand plan. You're asking for a lot of money for a lot of time, for 6 months, and you want people to come from all around the world and to be part of it. And
I should point out that the 6-month programme is the longest that happens here. There could be 4 or 1 month as well. So this is one of the biggest ones.
One of the biggest ones. And you also want it to be well founded in UK mathematics, because you want UK mathematicians to be involved, not just bring in all your buddies and ignore the locals. That's definitely not what we want to do.
And for the benefit of any listeners, it's roughly a third, or into thirds rather, that we can divide the participants. It's a third from the UK, a third from Europe, and then a third from the rest of the world. Yeah, generally. So
this is mathematics is a very international subject. It crosses across political and geographical and language and gender and all of those borders. There's no barriers that way. Only ones that people impose. But the mathematics itself is very international. And certainly the physical and other systems that people study are of interest all around the world. So there's no problem with that. And
you're a mathematician with an established career, as we discussed earlier. The first Professor of Mathematics, non-male at the University of Kent. So even then, did it feel like it was a big task to be taking on, or was it something that just sits well in your seniority?
Well, I'm here with 5 friends, so I'm very comfortable with that. We've all known each other for quite a long time, and we've all been participants in a big international consortium of mathematics called the Foundations of Computational Mathematics, which has a very big big international conference every 3 years. And so I've been meeting the people, my co-organisers at these conferences and at other meetings for quite some time, maybe 15 years or more.
Yeah. So that helps make you feel comfortable, I presume, in the process.
Absolutely.
Yeah.
Absolutely.
And having that weight behind you, I guess, as a group, you can prove that you're established and serious mathematicians who will be working on a program which has meaning in many different ways, I suppose. That's right. I mean, the subject itself has a longevity and a credibility to it. There's now a large body of work, and it's attracting very good mathematicians. So we're extremely happy with it. Yeah, that's. I mean, a big part. A program is made by its participants, and you mentioned there about inviting people from all over the world. Have you I presume there will have been people that you personally hadn't worked with or met before.
Oh, yes, of course.
Yeah.
Yes.
And
that's the point. The point is you want to meet good new people.
Yeah, as a member of staff here, the most exciting thing about being at work is seeing the mezzanine area and the shared working spaces full of people gathered around blackboards or conversing, and it seems to ramp up as the afternoon goes on. Often it gets to about 5 p.m. as we start to go home, the admin staff, and everyone's just in full flow upstairs. Is generally what happens. So that atmosphere must be nice, I presume.
Yes, absolutely.
Yeah, and going back to the sort of practicalities of the application. So what happens is you'll put together a proposal, you'll send it, it'll be looked at by the Newton Institute's Scientific Steering Committee, and in some cases it can be given the okay at that point. Sometimes it can be handed back and said you need to work on it a little bit more, but the reapplication is completely encouraged in most cases. Was it a smooth process for you guys?
Well, fairly smooth. I mean, it's such a large topic with so many possibilities that in a sense you're forced to make choices, and referees don't always agree with those choices, or they think that you should do something a little bit differently. So we did get some referees' reports, which were by and large very encouraging. And several of us were at a meeting in Barcelona, and I can remember sitting down in the old part of the university in Barcelona, and we were hammering out our response to the referees and how we might change the proposal. In a sense, the referees were helping us to make the choices that we needed to make. So it's actually a very helpful process.
Yeah.
And then you feel that you've got the referees are anonymous, of course, but I mean you feel that you have community support if people are not just supportive but making constructive criticism.
Yeah. And
trying to make the program better. And you don't always agree with the referees, but by and large,
yeah, sure thing.
But by and large, it was a positive process.
Yeah, absolutely. And then of course there's the time commitment, because for organisers obviously, and then for any program participants who are here generally for the length of the program, although they can come and go, 6 months is a long period to negotiate with your home institution and work out from a family point of view.
Yes.
All of these kinds of, they all present challenges, don't they?
Yes, they do.
How has that been for you? We're not too far, of course, from Kent.
No, we're not too far from Kent. I've actually taken early retirement because I just wanted to do research. But yes, I mean, I think that the staff of the Institute are fantastic at helping people come for periods of time in terms of facilities for children, for their schooling, for their care. Also, people who have caring responsibilities or who need carers themselves. And all of those kinds of barriers, the staff here and Christy Marr in particular are really working very hard to overcome those barriers, and it makes a big, big difference.
Yeah, Christy Marr, the Deputy Director. Yeah. And this actually leads on into something which we mentioned briefly before we started recording, and indeed ties in with your history as a trailblazer for women in mathematics in some way, which is that the gender balance of your programme in terms of speakers and in terms of the participants in general for workshops which take place during the programme or the programme as a whole is good in comparison to some others.
It's very good. Yeah. It's very good. All of us are very aware of the need for equality in diversity. I mean, certainly those that are on the rough end of it are certainly very aware of it. One of my co-organisers is Aria Isalees, who's the Professor of Numerical Analysis here in Cambridge, and he has been a mentor and champion for me for a very long time. I'm extremely grateful for his insight into my difficulties and in helping me to overcome them. And it's been so helpful to have that the women just aren't fighting for the women. It's just, I can't tell you how necessary it is for men to champion women in a way that's positive. I mean, a lot of people think, well, I'm not sexist, so I'm not guilty, and so I don't need to do anything. That's absolutely not the case. You do need to do things, because the reality is that even though very few people espouse sexism as an ideology, nevertheless, a sexist environment continues to be the reality for many women, and and you really do need to think. The real problem is invisibility with the invitations and the citations and the collaborations, and that invisibility is still needing to be overcome.
Yeah, that's really fascinating to hear, because it's saying that you can't simply be passive and benevolent, so to speak.
No, you can't.
Yeah.
You have to think if you're organising something or if you're writing your papers, who are you citing? You have to think now, have I really cited all of the work, and am I...
Yeah.
That blindness is still a step that people have to... It's still a positive thinking step that people have to go through.
Perhaps it's an unanswerable question, but given the current rate of change, when do you imagine we might be at a stage where that kind of thinking isn't required anymore, where it's just assumed? And
I think that it will always be necessary, because the research, the sociological and psychological research into implicit bias shows that it is endemic and pervasive, and there's always going to be somebody who will be invisible. So, there's a very long list, not just gender. And
yeah, exactly. I was the one that mentioned gender. I mean, you're using the term equality and diversity, so you're talking about other minority groups as well.
I think that it's so important to understand your own thinking processes, not in a judgmental way, but just in a real way, that this is the reality, and that you have to continue to make steps to be inclusive.
Yeah. And do you find that as a... I don't know why I'm shying away from using the word senior, because maybe it's because I'm worried that it sounds like old, but you're a mathematician at the top of their career.
Oh, thank you.
And do you feel a sense of responsibility as a woman to own some of this more than perhaps your colleagues? Do you feel that you're asked to be on too many boards or to be too representative of women in mathematics? Is there anything, a burden on your shoulders, or actually is it something that you're very happy?
I'm very lucky that my colleagues have taken up the baton, and I no longer fight it alone. There was a point where I did go to the Vice Chancellor at my university, and he, at some point in the conversation, this was before I was promoted, he realised that I was not working at the institution he thought he was running. Right. And that's and this is why you can't just a manager can't just say, well, I'm not sexist and therefore the environment's not sexist. That's simply not doesn't follow. Yeah. So he made significant changes, and that was incredibly helpful. That was back in the early 2000s. And so I do, and my colleagues in my school in Kent have worked incredibly hard to have a really good environment. And it's not just, interestingly, the numbers of my junior colleagues who have caring responsibilities for children are equally men and women for a variety of circumstances. So in fact, we've worked very hard to have a really good environment, and I feel very fortunate. I've been allowed to say no to... I don't sit on a lot of boring committees. I've been allowed to just say yes to the ones where I feel that suit me or that I have something to say. That's good. But certainly I do attend those committees with a view that I've not been invited as the token woman. I'm there for myself, and I give my opinion, and if they don't like it, they don't need to ask me back. Quite often they do ask me back. Very good. So I go to make a difference by being my authentic self.
We're very fortunate, I think, that we have someone with this kind of thought process and this kind of experience organising a programme here. It couldn't be more helpful.
Thank you. Yeah. But I'm not doing it alone. My colleagues.
No, indeed.
My colleagues very much share my point of view.
Yeah, excellent. And we are, of course, quite near the beginning of your programme. So there's we're in the height of the summer now. It's extremely hot today, but by the time you finish, it will be quite the opposite. So how excited are you about what lies ahead for GCS, as we shorten it?
Oh, I think with such a diverse, intellectually diverse as well as person diverse group, that the possibilities are immense. I expect for many of the younger participants that the opportunity will be life-changing, that will change their direction. That certainly was my experience as a junior person at a similar program in Berkeley. That was certainly a life-changing event. And for myself, there's just so many interesting things that I'm really thinking that what will I take up next, and what will be my next big challenge. Mathematics is such a wonderful thing to do. I feel very privileged to be here in this kind of environment and able to participate in different things and different people. I'm already having people knocking on my door wanting me to explain something, and no doubt I'll be knocking on other people's doors. And yes, hopefully start up some collaborations and with things that use my particular expertise.
That's wonderful. Well, it's a very exciting road ahead, and it's a pleasure to have you here. As I say, I look forward to covering everything that happens with GCS in the coming months. But Elizabeth, it's been a pleasure. Thank you so much for joining me. And again, I'll catch up with you. We'll be recording your talks. I'll be talking to you more, I'm sure. And yeah, thanks again.
Thank you.